Now you can see the screen. So now we have to here we have to convert the following epsilon and fa to DFA. Okay, so what is mean 4 to 5? This is the representation is given, symbol is epsilon. Yeah, maybe sometimes they will give in the lambda. So this one means epsilon means free path. Okay, to go from 1 to 2, this is state, we not required any input. Epsilon means if you don't have any input, then also you can reach from 1 to 2. Yeah, 1 to 4. Okay, 4 to 5. But 5 to 8, we cannot go freely because we required input symbol A to reach from the state 5 to 8, 5 to 6. Okay, so understood the epsilon meaning means freely path. So here 1 to 2 is free path is there. So the same conversion you have to do by the way which we have done in the last class, that NFA method, NFA to DFA, but just we have to take care only the starting state. Okay, so the same method we will apply, but we have to just take care of the starting state is what here. So here input symbol first will decide. Here input is A and B. First we will see the start state. So start state is what? 1, right? That 1 is the start state. If any path is there which is epsilon, it's going freely, that also you have to consider as the start state. Getting here? So 1 to 2 directly freely you can go because there is a input symbol is epsilon. Since we can go 1 to 2 freely here, this is also you have to consider as a start state only. That is 2. Here 4 also you can go. 5 also we can go. So this all will be the starter. So we cannot go to the 3 without taking the input A, right? So A is not epsilon here. So we cannot write 3. If consider here is epsilon not given as something B is given here, so I should not write 2. That time only 1, 4 and 5 should be there. If epsilon is there, then only you can consider as that is also a starter state. Getting? If the example consider given like this, Q0, A and B is Q1, and here something Q2 and any epsilon path here is there. So only a starter state will only Q0. Getting? Because from the Q0 there is no any free path from anywhere. Okay, so Q0 is the started state. So we have to consider Q0 as a starter state, but since there is no free path, we cannot write Q1 and Q2 anything. Okay, if here is mentioned epsilon, then you should consider as a Q1 here, because from the Q0 to Q1 you can go freely. No doubt. So this is only the point you have to keep in mind while only taking the starting conditions. Now it will be the same as the NFA. 1 to A. 1 to A is what? 1 to A is nothing is there, right? There is no symbol from 1 to A anything. 2 to A. 2 to A it's going to 3. 2 to A it's going to 3. Here I will write it 3. Next 4 to A. 4 to A is 4 itself. Okay. 4 to A is 4 itself, and we can go to the 5 also, because this is the epsilon path. Okay, you have to just keep in mind here if 4, just consider here 4 is your room, and 5 is another room which is connected to 4, and that freely you can go. So when you start roaming at A, so you can freely go to the 5 also, right? Because there is free path is there. So 4 to A is 4, and since freely you can go, then we have to consider as a 5 also, because 5 is epsilon product. 4 to 5 is epsilon production is there. Means 3 path is there. Getting? Next, 5 to another you cannot go without any input symbols, right? So there is no 3 path. Next 5 to A. 5 to A is 6. So that is also calculated. Next to check for the B. 1 to B is nothing. 2 to B. 2 to B also nothing is there. 4 to B. 4 to B also is not there. 5 to B. 5 to B is 5. And 6 also no, because 6 required A. Only 5. Right? Any doubt in here? So any new state, this is 3, 4, 5 and 6 is the new state. So I should write it here. This 5 is also the new state, so I should write it here. No doubt. If any doubt, then you ask. So now you have to check the same thing. 3 to a. 3 to a nothing. 4 to a. 4 to a is 4. 5. 4 to a is 4 and 5. 5 to a. 5 to a is 6. And 6 to a is nothing. So 4, 5, 6. 3 to b. 3 to b is 2. 3 to b is 2. 4 to b. 4 to b is nothing. 5 to b. 5 to b is 5. And 6 to b also is nothing. So new state has come. That is 4, 5, 6. And 2 and 5. So you keep writing. So you will not forget here. Any new state. Now 5 to a. 5 to a. 5 to a is 6. And 5 to b. 5 to b is 5 itself. So 6 is the new state. I should write it here. 5 is not the new state because 5 already we have written. So 4 to a, you check out 4 to a. 4 to a is 4 and 5. 4 to a is 4 and 5. 5 to a. 5 to a is 6. And 6 to a is nothing. 4 to b, nothing. 5 to b, that is 5. And 6 to b is nothing. So this 4, 5, 6 already we have considered here. So no any new state. And 5 also we have already taken. Next 2 and 5. 2 to a. 2 to a is 3. And 5 to a. 5 to a is 6. This is the new state. Next 2 to b. 2 to b is nothing. And 5 to b. 5 to b is 5 only. So the new state is 3 and 6. 6 to a. 6 to a is nothing. So you can write 5. 6 to b is also nothing. 3 to a. 3 to a is nothing. 6 to a also nothing. 3 to b, which is 2. And 6 to b also nothing here. So new state has come 2. 2 to a. 2 to a is 3. And 2 to b. 2 to b is nothing here. So new state has come 3. Next is 3 to a. Nothing. 3 to b is 2. 3 to a is nothing. 3 to b is 2. 2 is already we have written here. So new state has not come. So we have to stop. Any doubt till here? So this one already we have done in the last class. So now you have to just rename the numbering A, B, C, D, E, F, G, H. Let's consider this one is I. Okay. Any doubt till here? The transition table here. Okay. That now DFA. So A2, this one you can write numbering the same thing which I written here. This is B, this is C. And this is 4, 5, 6. That is D. 2, 5 is E. This 6 is F. That 5 is C. 4, 5, 6 is D. C. 3, 6 is G. 5 is C. This is nothing here. 2 you can write here H. And 3 is I. And this is 2 is H. Okay, so we'll do it. A to a small a it's going to the B, right? Yeah. And A to a small b it's going to C. It's going to C. Next, B to A is D. B to A is D. So let's consider B to A is somewhere here. That is D. and B to small b is E. C to A is F. C is to A is F. So F somewhere here, that is going to F. And C to B is C itself. Okay. C to B is C itself. Next D to A is D itself. D to A, D where? It is one. D to A is D. And D to B is C. No doubt?
No.
Now E. E to A is this one. E to A is G. So G is not here marked here, so you can write it here somewhere here. E to A is this one is G. Okay? And E to B is C. E to B is somewhere here, I will write it here. This will be easy to draw it, okay? E to A is G and E to B is C. Getting? Next, F nothing. That G to that B is H. G where? This one. G to B is H. H to A is I. This one. Okay. And I to A is nothing. I to B is H. This one. Getting it?
Yeah.
So this one you can write it here.
Yeah.
So now see here what you can do it here. This one, this part, which I am marking as a different color. This part from here.
Yeah.
This whole part be this E. That GHI.
Okay.
This GHI. You don't have any incoming degree. Okay, from the E. So you can delete it. This one. This is no use here actually. This is just like a dead state. If you write also no problem. So this is the answer, you can write it.
Okay.
Okay, so what will be the final state here? In the question, final state is what? 2 and 6. So the state which having the 2 and 6 will be the final state. Which one will be the 2 and 6? That state will be the final state. Right?
Yeah.
Just check out the which state you having the 2 and 6. So this one is there. Here 2 and 6 is there. So this one here, this one C naught, this one's D, E, F. Okay, and this one you can, if you don't write then also is fine, because after 5 has come, no. If you write nothing then also is fine. If you don't want, you can write it here.
Okay.
If you don't want, you can leave it here. So A, B, C naught, D, E, F. D, that E and F will be the final state. Getting? If you want to overall to write it here, the G, H, and also you can write final state G and H, but this is not required to write because this don't have any. This is just like a trap state, which I have already discussed in the last class. The trap state is there, not necessary to draw it. Getting any doubt in this?
No.
So we have so minimization of DFA is the next topic here. Now what will happen here? You consider if you have given the several state. Okay, several state means like consider somebody has asked to design the DFA. Okay, a DFA they ask for design here. You have designed by taking the 4 state. Q0, Q1, Q2, Q3. Let's consider here. You have designed by taking the 4 state, and somebody another designing the same DFA, same abstract machine by taking the 3 DFA. Yeah, 3 state. Getting? So this DFSM will be called as a more efficient because it's having the less number of state, and it's doing the same task the DFA which is one doing, right? Okay. So here we have you have used here 4 DFA, 4 state, which means this is also correct, this is also correct, but this state having only 3, so this DFA will be the more efficient compared to the DFA one. So that's why you have to minimize this DFA. This is 4 state is there. You have to minimize the number of states and make the abstract machine as more efficient. Getting what is mean by the minimizations? So if you are having the DFA here, minimization means we have to take the least number of state to make it more efficient DFA machines. Okay. So now consider. So I will write it here first. Definitions. Minimizations of DFA. Yeah, DFA means minimization means minimal version of any DFA which consists of the minimum number of state possible. Getting minimum number of state possible. So if you having the 5 state here, I have 4 state here, and this having only 3 states, so this will be the more efficient compared to the DFA one. Okay. So what we have to do? We have to minimize. The minimization means what we actually have to do it here. We have to combine 2 states and make it only one. Okay, we can combine 2 states together and make it one. That's why this one also is what having the same DFA. It's working the same abstract machine. So here it's what more efficient means they have combined 2 state and merge it as a one only, right? So when we can combine, I'll write it here. We can combine 2 state when it will be equivalent, right? When we can combine 2 state when a state are equivalent. Equivalent means like here, consider 2 state A and a state B. 2 state A and B are said to be equivalent if any transition from A to X, it's going to the final state, and same it's happening for the B also. B for the same input, it's going to the final state. If the same final state is going, then it's said to be A and B are equivalent. Okay. Yeah. If both are not going, delta of A to X is not going to the final state, and delta of B to X also is not going to the final state. Getting here? Means A to B. If same input is there, then either it's going both final state, yeah, both is not going final state. So meaning that does not go to the final state. So these two condition holds, then we can say that this is said to be equivalent. Getting? Okay. So now the type of equivalence. So type of equivalence here. First one is if given the here 1. If length of x is equal to 0. Okay, length, I will tell you what is mean by length here. First steps. If x modulus of x is equal to 0, then A and B are said to be 0 equivalence. Yeah, 0 equivalent. Getting? Similarly, if same thing, if the length will be 1, then it's said to be 1 equivalent. If modulus of x is equal to 2, then it's said to be 2 equivalent, and so on. Modulus of x is equal to n, then it's said to be n equivalent. Getting any doubt in this? Okay, so let's see the example here. Consider is given here questions. Q naught to B, it's going to Q naught itself. Q1, that is A. There also A is there. This is B, Q3. This is the final state also. Q4. So this is the question is given. We have to minimize this state automations of this transition. You have to do the minimizations actually. Okay. So better if any questions is given in the DFA forms, you make it the transition table. Okay, transition table, if you make it, it will be easy to determine the values. That's why every question you write the transition tables, that A and B. That Q naught, how many state is there totally? Q naught, Q1, 2 up to the Q7. Q naught, Q1, Q2, Q3, Q4, Q5, Q6 and Q7. Tell me the first value. Q naught to A is where it's going?
Q1.
Q naught to A, it's going to the Q1, and this is Q naught itself. Q1 to Q naught, Q2, Q2, Q3, Q1. Next, this is Q3, Q naught, Q4, Q3, Q5, Q5 which is going to the Q6 and Q4, Q6 is going to the Q5 and Q6, and Q7 is going to the Q6 and Q3. Yeah, sometimes they will give in the DFA form also, then you draw the transition tables like this. So it will be easy to us to find it, the method which you are going to teach you to minimize. Okay, and here we know that the Q3 is the final state because in the question was mentioned Q3 is the final state. Yeah, you can mark it a circle, yeah, star, and Q naught is the starter state. So now first state, we have to make it all the final state together and non-final state together. Okay, you have to do the partitions in such a way that the final state will be the separate and non-final will be the separate. Getting here?
Yeah.
So just I will write it here. Step 1. We will create a set that name is considered as pi naught, which is Q1 of 0 and Q2 of 0. Okay, where Q1 of 0 is set of all final state and Q2 of 0 will be the remaining, and total state minus Q1 of 0. Getting? Okay, so non-final state, I can write it. So just do the step 1. So I can write pi naught is equal to final state. Final state is which one? Only Q3 is there, right? So this one you write as a separate, and non-final state will be separate, which is remaining all. Q naught, Q1, Q2, then Q4, Q5, Q6 and Q7. This one. Okay. Now we have to step 2. Now we'll create the we have to do it pi of k plus 1, means all the 1, 2, 3 and so on we have to make it. And what is the rule here that I am going to teach you here? First we have done non-final state separate, final state is separate. Any doubt in this one? Step 1 in doubt? Now see here. This pi 1 means 0 equivalent. This is pi naught means 0 equivalent. 0 equivalent. And pi 1 I am writing here means 1 first equivalent. And so on. So here pi 1, which one is the same? Which is the only this Q3 is a single only. So this one you cannot partition, you cannot do because only single is there, right? Now which one group is there, that one you check out. Like Q0 to Q1 you check out. And if you both going in the same state, so in the first step no doubt. Now in the pi 1, so here which one is the group is there, like this all is the in the one set. Okay, you have to split here. So how to check out here? You check out Q0 and Q1 individually each to set. Like consider first one is Q0 and Q1. You check out for both input A and B. Whatever the value it's coming, this one and this one. If you lie on the same set, then you have to not split. Getting? If you lie in the different set, then you have to split. Getting here? So let's consider first one I am taking for Q0 and Q1. So what is the Q0 and Q1? Q0 and Q1, you write Q0 to A is, I will write it here, A and B. Q0 to A is going to the Q1. And this is Q0, this is Q0, and this is Q2, right? So Q1 and Q0, this set. Check out this set should be lying on the same set. So Q1 and Q2 is, Q0 and Q1 is what? In the same set now. Okay? Same set means this set you have to check out. Q0 and Q2. Q0 and Q2 is also lying on the same set. So this Q0 and Q1 will be not split. Because that value of A and B is coming to the same set. In doubt?
No.
Similarly, if you check for the Q0 and Q0 over Q0 Q2. Q0 and Q2. So Q0 to Q1, what is the values? Q1 and Q3. Q1 and Q3 lie on the same set? No. Q1 is lying in this set, Q3 is another set. Getting?
Yeah.
So Q2 will be the separate from the Q0. So I will write it here another set, which is Q2 will be different set from the Q0. No doubt in this. You have to just split. No doubt?
No.
Similarly, you check for the Q0 Q4. Q0 Q4. Q0 and Q4. This is Q3, this is Q1. So Q3 is the different state. So we'll go to the split here. Q0 Q5. Another no need to check here. Only one should be. Q0 to Q5. This is Q6, this is Q1. Q1 and Q6 lie on the same state. So Q5 also will be lying on the same state. Getting?
Yeah.
Similarly, Q0 to Q6. Q1 and Q5. Q1 and Q5 lie on the same state, so Q6 also will be not split. Getting?
Yeah.
Next, Q0 and Q that you have to check both actually, both you have to check out. Okay, this one you cannot decide with only one. Q1, Q5 is the same state, Q0 and Q4, 6 also is the same state. Next for the Q0 and Q7. This and this. Q0 and Q7 means Q1 and Q6. Q1 and Q6 lie in the same state. And for the B, Q0 and Q3. Q0 and Q3 lie on the different states, so Q7 also will be split. Any doubt in this?
No.
Understanding? You have no? Yes. Understood everything? So this is the first equivalent. Now, step 3 you have to continue same thing. Pi 2. Q3 is single only, so no problems here. Now again you have to check is the Q0 Q1 again. Q0 Q1. So Q0 Q1 means Q0 and Q1 is together only, and Q0 and Q2. Q0 and Q2 is what different state, right?
Yeah.
Q0 and Q1, if you are checking here, this is Q0, this is Q2. So we'll go to the different state. Getting?
Yeah.
So now Q0 is here, and Q1 will go to the different state. Q0 and Q5 you check out. Q0 and Q5. This is Q1's Q6. Q1 and Q6 is the same state. And Q4 and Q0. Q4 is different state, Q0 is different state. So Q5 also will be split. Getting?
Yeah.
Now Q0 to Q6. Q0 to Q6. This is Q1 Q5. Q1 Q5 in the same state. And this one is Q0 and Q6. Q0 and Q6 is the same state. You have to just check in the previous state. Okay. So Q6 will be together only. So this one is already done. This one will check out. Q2 and Q4. Q2 and Q4. Q3 in the same state. Q3 is there. And this one here. Q5 and Q1. Q5 and Q1 also in the same state. Together. Okay. Getting here?
Yeah.
So this Q2 and Q4 will be together. Next, Q2 and Q7 will check out. Q2 and Q7. Q2 is this one and Q7 is this one. So Q3, Q6. Q3, Q6 lie on the same state? No. Okay. So we'll go to the different state, which is Q7. Getting?
Yeah.
Next step pi 3 means step 4. Q3 single is there, no problems. Q0, Q6 check out. Q0 and Q6. Q1 and Q5. Q1 and Q5 lie on the same state. Q1 and Q5 lie on the same state. And this is Q6 and Q0. Q0 and Q6 also lie in the same state. So it will not exclude. Getting?
Yeah.
Next Q1, Q5 will check out. Q1 and Q5. That is Q0, Q6 lie on the same state. And this one is Q4 and Q2. Q2 and Q4 also lie on the same state. So it will not break. Getting here?
Yeah.
Q1 and Q5 will not break. Next Q2 and Q4 check out. Q2 and Q4. This is Q3 lying on the same state. And Q1 and this is Q5. Q1 and Q5 also lie on the same state. So it will not split here also. Q2 and Q4 will be same only. Okay. And Q7 is already single only, so no need to check on. Any doubt in this?
No.
So last state and this state, two steps are equivalent, then you have to stop. And now we have to merge it together.
Okay.
Which already there is set together, that is have to merge it. Getting here? So now just I will write this transition table, that only have to write it this one. Which one is there here? No. Like here Q0, Q3 is single is there, Q0 and Q6. Q0 and this Q6, this one. You have to merge it together. Getting?
Yeah.
So I will write it like this one here. How many state is there? All you write it together. Q0, Q6. Then Q1. You can write in any order, no problems. Q5. Q2, Q4. And this one is Q3. This is Q7. Okay. This is the starter state. And the final state will be the Q3 only, right? This is Q3. Now we have to, each corresponding A and B have to do it. I will copy it this one here, so it will be easy to us to check out which value I am writing it. Okay. I will write it here. Okay. So now see, now it will be easy to us to copy it here. This is A, this is B. Q0 to where it's going? Q1, and Q0 to A is over Q6 to A. Q6 to A is going to the Q5. Okay, this one together. And I already know Q1 and Q5 is together now. Q0 to B is Q0, and Q6 to B, Q6 to B is Q6. Okay.
Yeah.
So it will come all the state which is together only. See here, Q0 and Q6 is coming same, and Q0 Q6 already there in this. Getting? Q1 to
Yeah.
A. Q1 to A is going to the Q0, and this is Q6. Similarly, this one has a Q2 and Q4. It's coming in the same state. Same set all it's getting here. Q3. This is Q1 and Q5. This Q3 to A is Q3. This is Q0 Q6. Q7 is here Q0 Q6. And this is Q3. No doubt in this? Okay, now if you want to write here A, B, C, D name, and you can draw the DFA. This is B, this is A, this is Q0 Q6 is which one? A, this is C, this is D, B, D, A, this is Q0 Q6 is A only, right? And this is Q3 means the D. Okay?
Yeah.
Now you can, all the state you can draw it here. Means A to a small a, it's going to B. A to a small b, it's going to A itself. B to a small a, it's going to the capital A. Okay? And B to a small b, it's going to C. C to A is D. Okay? And D to A is B. C to A is D, and C to B is C to B, small b is capital. This one. D to A is D itself, and D to B is A. E to E is another state which is given here. E. E to small a is going to A. Okay? And E2 is going to the E2B is going to the D. Getting here? So this is don't have any in degree, you can delete it also because this is don't have any in degree. This is just like a trap state. Here you can draw it this one, and you can write the final state which is C. So this is after the minimization. So here the question was here how many state with 1, 2, 3, 4, 5, 6, 7, 8 state was there.
Yeah.
Now after the minimization we got it only in the same DFA with the only the 3 and 4 and 5. This is also you can eliminate. So actually only 4 state. Okay, so this is called the minimizations. Any doubt?